Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you. Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up. And check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you. Before we begin, a note from our sponsor. I'm Richard Jacobs, Executive Director of the nonprofit Finding Genius Foundation and host of the Finding Genius podcast. In late 2016, I was rear-ended at 65 miles an hour by a truck on the highway, which sent me off-road into a ditch. The impact of the collision gave me a concussion and other injuries. At the hospital, a CT scan showed that I had thyroid nodules, which turned out to be cancer. It was then, when I had a biopsy in my neck, that I realized even if I was a millionaire, I wouldn't want a second or a third biopsy due to the pain and the invasiveness of it. And appointments at that time for thyroid experts were 3 to 6 months out, and I was worried about dying now, even if that was irrational. So because of this, I've decided to raise money to conduct a literature review on steroids on the causes of anxiety and depression, a condition that affects well over 50 million people in the United States and hundreds of millions worldwide. Our goal is to create a codex, a guide that reveals all possible treatments for anxiety and depression for people that live with the condition or for loved ones that have it, as my wife and my son do. To find out more about our fundraiser, visit findinggeniusfoundation.org and click on current initiatives. And now, to our guest.
Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius podcast, now part of the Finding Genius Foundation. I have Chima McGruder. He's a graduate student at Harvard. His research interests include exoplanet atmospheres. The fifth-year grad student, part of the Harvard Center for Astrophysics. Again, he studies exoplanets. So we're going to talk to him about his work, his research, et cetera. So Chima, thank you for coming.
Yeah, thank you for having me.
Yeah, I also saw in your bio that you had some interest or interaction with the James Webb Telescope. But tell me a bit about the graduate work that you're doing, and does it overlap with James Webb or not? Is that part of your exploration of exoplanets?
Yeah, so the James Webb works in the infrared, the mid-infrared, and what I work on mostly is the optical. So like most of my observations are ground-based. And so though the wavelengths that James Webb and what I work on don't overlap very well, they do complement each other very well. And the way it does it is because in the infrared, you observe mostly optical molecular features, whereas in the optical, you're observing atomic features. And in the optical, really constrains the level of aerosols or clouds and hazes that are in the atmosphere of the planet. And without that kind of constraint that you get from the optical, the amount of or the abundance of the molecules observed in the infrared is more ambiguous. So there's a degeneracy between the amount of the molecule that you observe in the infrared and the amount of clouds that is obscuring those molecules. So with the optical data, we complement what the James Webb infrared data gives.
Oh, okay. So what's I've seen an image of Jupiter, but what exoplanets has James Webb looked at so far that you've been able to take the data from and then incorporate into your own analysis?
Right. So yeah, James Webb just started, but actually the first exoplanet that James Webb observed was WAS-96, and it complemented the work that I do quite well because WAS-96 is the paper that I just finished working on in the optical, of course. Oh, just as a preference, WAS-96, as well as most of the planets that we observe, are very different than Jupiter, which is far away from the host star, gas giant. Whereas the planet like WAS-96 is much closer to the host star, but still a gas giant. So the term is called a hot Jupiter. Observations that I took and analyzed with WAS-96 and the optical complement the James Webb observations of WAS-96 because, as I was saying previously, it's hard to determine the absolute amount of molecules observed from what James Webb's attained without constraints on the cloud level. And in fact, WAS-96 is, from the optical, suggested to be one of the clearest, so the least amount of aerosols, so clouds and hazes, gas giant that we've observed, our hot Jupiter that we've observed. And the James Webb data that released 2 or 3 weeks ago of that target, there was multiple models that just using the James Webb data suggested that it had more or less clouds. And when you incorporate the optical data, that really starts to discern the level of clouds and the overall abundance determined for that planet.
So what does that tell you? What's useful about knowing more accurately the cloud levels?
When we're observing hot Jupiters, there's a lot of phenomena that we don't understand about them. So from the back before we understood about hot Jupiters, our understanding of planetary formation was that the larger planets form further from the star, and they more or less stay around where they formed. And the reason that the larger planets form further from the star is because that there's much more available material further away from the star you are, because the volatile material can condense down to coalesce onto the planet. But then since the discovery of hot Jupiters, we've been very confused on what's going on because these planets are Jupiter-sized but very close to the star. And so the fact that they're so close to the star either means that our understanding of condensation of materials is very wrong, or the planet has migrated over time. Understanding the molecular composition of these planets allows us to constrain either when the planet migrated, so at what point in its formation lifetime it migrated, and where it initially formed. So when you get a constraint on the cloud levels, that allows you to get a constraint on the molecular abundances, which then allows you to discern where the planet formed and when it migrated.
Okay, so I mean, what have you learned that's new about these exoplanets you're studying?
So for WAS-96 specifically, and a recent planet that was also observed from James Webb, WAS-39b, we're finding high metallicity. And in astronomy, metallicity means any molecule that's not hydrogen or helium. So we're finding high metallicity and low C/O ratios, and C/O ratio is carbon to oxygen. This low C/O ratio and high metallicity tells us that the planet either formed really close to the water snow line, so about where Jupiter is, so around 5 AU from the host star, or it migrated, it formed further out and migrated early on, closer to the host star to collect sufficient amounts of oxygen-bearing species to cause the C/O ratio to be so low. From the James Webb observations, in conjunction with constraints on optical data of the cloud levels, we can point our science in that direction of the fact that the planets are indeed forming relatively close to the water snow line, so around 5 AU. So AU is astronomical units, so like 5 AU is about where Jupiter is right now, which was a little bit muddy, which was much more muddy before.
I mean, what useful new information are you getting from these, this analysis? Like, you're just better understanding the atmospheric composition, or, like I saw someone like the James Webb images. It looked like Jupiter had maybe a series of small moons that might not have been known about, or rings that might not have been known about. What are some of the things that you'll learn with this new information?
Right. So we did not previously have strong constraints on, or at least based on the molecular composition of the planets, on where they formed and when they migrated. So that is the new information that we've obtained just from 4 weeks of data from James Webb, is that we're now able to constrain the abundance of the molecules, which then gives us much more insight on where the planet formed and migrated to. So that is the new information that we've gained so far with James Webb, and there's much more that we intend to probe and learn from James Webb past these 4 weeks of operation.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now, back to the show.
Well, are there any combined images where Hubble had a look and then James Webb looked at the same exoplanet? And perhaps you can use that combined data to get a much better picture.
Yeah, so that's kind of like what I'm doing from the ground. And so, so the thing with James Webb, it is in the infrared, whereas Hubble is in mostly the optical or near infrared. So when we do combine these images, which we are doing, so for example, WASP 96, there's a paper being led to combine the optical observations, which includes HST and ground-based data, and the James Webb observations to get a much better picture on that specific target. And so what the goal is when using James Webb is to combine optical and other space-based instruments like HST data to get a better constraint. So like what I was saying earlier with the cloud levels is you need the optical, so either HST or ground-based data to get a constraint on the cloud levels, then use the James Webb data to get really well-defined measurements of the molecular features, and then combining those two, then that's when you get a much stronger handle on parameters like the metallicity of the planet and the CDO ratio, which then allows you to really fine-tune where and how the planet formed.
So what are some new things you realized about planet formation that's different from what you thought before?
So there are many theories on planet formation, and I wouldn't confidently say that this one observation two observations so far of WASP 39 and one of 96 can confidently say how all hot Jupiters form. But the new insight that it's providing is it's strongly suggesting that they do form pretty much where we are seeing planets like Jupiter in our solar system forming, or if they form further out, they migrate close to where we're seeing Jupiter very early on in their lifetime. And that is something that we have suspected before. There were theories that suggested that, but it's being confirmed or strongly supported by the observations that we have so far.
Okay, so are there any particular planets that you want to observe that you think will have specific learnings for you?
Yeah, so right now I've been talking about hot Jupiters a lot, but one of the amazing things about James Webb is that it will have the capability to observe a few smaller planets. Not many, but a few close-in planets can be observed with James Webb, and the hope is to get more understanding of the molecules that survive on those planets and begin the search for biosignatures on those planets. So that's really where I'm excited to see the new instrument lead us, or the new telescope lead us.
Okay. What's your end goal with studying exoplanets? Are you trying to determine again what their life cycle is like, or where the likelihood of ones that may contain life may be? Like, what are some of your goals with the research?
Yeah, so I mean, the long-term goal for, I think, a large portion of exoplanet scientists is to find or possibly find signs of life on other bodies. And in doing so, that would answer multiple questions. If we're alone in the universe, how difficult it is for life to form. So if we don't find anything, does that just mean that we're extremely lucky in the cosmos? And how likely it is for organisms to form in the not in the solar system, but in the universe. So that's the long-term agenda for me as an exoplaneteer. But additionally, I think the reason I'm starting with large planets, so hot Jupiters, is one, because they're easier to observe. And because they're easier to observe, you can determine much more about their atmosphere. And from doing that, you learn a lot with planetary formation and planetary statistics. So the total population of the planets, the atmospheric composition of planets out there in our galaxy.
Okay, well, very good. You have James Webb's schedule of scheduled viewings. Is there anything coming up in the near term that you're excited about? Like, does the public know what's coming for James Webb, or is it kind of like, it's a black box and whatever new comes out, everyone rushes to look at it, but has no idea what's coming next?
So there is a schedule, but the schedule is forever changing for multiple reasons. So, for example, WASP 96, I didn't know about WASP 96 release of data until a few weeks after it was, before it was released. But the tentative plan is available on the NASA website. But the biggest thing that I think should be noted that they have scheduled and is already starting to produce data for is that something that I've already mentioned is WASP 39. WASP 39b, it's another hot Jupiter. And this planet is being observed by James Webb for 4 of its instruments, so NIRCam, NIRSPEC, MIRI, and NIRISS, which each instrument has different wavelength coverages, although they do overlap, have some overlap in wavelength. And when we're observing this, we're already starting to find out new science from this planet and understand the instrument much better. So because we're observing this one planet, which is actually relatively clear, so very little clouds and hazes, that allows us to fine-tune the little quirks of each instrument, which is going to allow us to probe other planets more precisely and accurately. The observations of WASP 39 have already started. 2 of the instruments are available. Observations of 2 of the instruments are now available, and the other 2, NIRISS and MIRI, will be observed within the James Webb site. But yeah, it's because of scheduling gymnastics, you want to optimize the usage of James Webb. The exact dates of observations have been changing pretty often. So I wouldn't confidently say a specific date when the next observation.
Okay. Well, very good. Where can people find out more about your work with exoplanets? Where can they go to learn more?
Yeah, so to find out more about James Webb, you can go to the NASA website. You just type in NASA James Webb, and I'm sure it'll be the first link. And it shows all the approved early release missions and the PIs and co-Is of those. To find out more about my specific work, I work in the optical. And the work that I do in the optical is done with the research group called Access. So you can find that on the Access website. So you, again, go to Google, type in Astronomy Access, and it should be the first link. And for me, specifically, I'm working on my PhD thesis. And that information all the papers are going to be published on Archive, which is a free publication website that anyone can access. And you can easily look up my first and last name. And I think that's where you can get all the information you would need.
Okay, very good. And your first name, Chima, Chima, And then last name, McGruder. Is that right?
GRUDR, that's right.
Oh, DR, McGruder. I'm sorry. Very good. Okay. Well, Chima, thank you so much for coming on the podcast. I appreciate it.
Yeah, thanks for having me.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.